your head yes, but you wanna say no.
What do you mean? I mean geometric mean. So in 7.5, the last section that's going to be on our Unit 7 test, we're going to be looking at geometric mean. So we're going to use geometric mean to find segment lengths in right triangles. And we're going to apply similarity relationships in right triangles to solve problems. So we'll be taking a look at geometric mean, and we'll be like, geometric sounds like geometry. Mean comes from like mean, median, and mode, which is statistics, and you are taking the square root to both sides using the square root property of equality, and that's algebra. So, is geometric mean geometry, statistics, or algebra? Well, as you'll see, it's a little bit of everything. All right, so let's start off by we're going to be looking at this triangle here, okay? And what do we call segment CD? It goes from the vertex and is perpendicular to the other side. It's called an altitude because it's perpendicular to the other side. So what we're going to do is verify that triangle ABC is similar to triangle ACD. So we know that let's do green. We know that angle BCA is congruent to angle ADC by the right angle congruence theorem. Then we know angle A is congruent to angle A by the reflexive property of equality. Reflexive. So if you're like saying like, Mr. Jameson, we learned these a long time ago. Well, you did, but they're coming back for you. So we know that triangle ABC is similar to triangle ACD because of the angle similarity. We have the right angles and we have angle A. Okay, so we know the big triangle is similar to the medium-sized triangle. Is the big triangle similar to the small triangle? Or yeah, BCA. Yeah, is a big triangle similar to the small triangle? Well, let's find out. So we know that angle BCA is congruent to angle BDC also by the right angle congruence theorem, right angle congruence theorem, because both angle BCA and angle BDC are right angles. Now, both triangles include angle B. So angle B is congruent to itself. And that's because of the reflexive property of congruency. It's congruency because angle B is an angle and angles are congruent. Remember, measures are equal. Now that's going back to Unit 2. Okay, so we know that these triangles are similar. So triangle BCA is similar to triangle BDC also by angle similarity. And so by the transitive property of similarity, we can say that triangle ABC is similar to triangle ACD, which is similar to triangle CBD. So the altitude of the hypotenuse of a right triangle forms two triangles that are similar to each other and the original triangle. So just in case we forgot, right triangles have an hypotenuse, which is across from the right angle, and then 2 legs. So BC and AC are legs. And we'll be calling one of the legs the long leg and one of the legs the short leg. All right, so we have the same figure. We have A, B, and C sides of the big triangle. We have H, B, and Y sides of the medium triangle. And we have A, H, and X sides of the small triangle. So big, medium, small. Okay? They're not always going to be big, medium, small. They could be big and then small and small. They could be equal to each other. So let's look at the short leg of each of the triangles. So short leg over long leg. So looking at the big triangle, the short leg is A and the long leg is B. So we're not looking at the hypotenuse. So it'd be A over B. Now let's look at the next one, the medium triangle. Short leg is H, long leg is Y. So H over Y. So A over B equals H over Y, which equals X over H because it's the short leg over the long leg of the small triangle. So A over B, H over Y, medium triangle, X over H. So we'll always do big, medium, small triangle. Big triangle, medium triangle, small triangle. Okay. So now let's take a look at short leg over hypotenuse. So the short leg of the big triangle is A over C. The short leg of the medium triangle is H, and the hypotenuse is B. The short leg of the small triangle is X, and the hypotenuse is A because it's across from the right angle. So X over A. And then long leg over hypotenuse. So the long leg of the big triangle is B, and the hypotenuse is C. Long leg of the medium triangle is Y, and the hypotenuse is B, across from the right angle. And then for the small triangle, the long leg is H, and the hypotenuse is A. Now, interestingly, all of these, if we were to set proportions, there's something interesting that happens. So there, with the short leg over the long leg, we get H squared, H times H equals X times Y. H squared equals X times Y. For short leg over hypotenuse, we get A squared over A squared equals C times X, or X times C. A squared equals X times C. And then lastly, we get B squared equals YC. There's kind of a pattern going on here. So let's take a step back and talk about what geometric mean means. So if we have two positive numbers, so the geometric mean of two positive numbers is the positive square root of their products. So let's say we had 2 and 6. The geometric mean of 2 and 6 is the square root of 2 times 6. And we can represent this as either x equals the square root of a times b, or like basically taking the square to both sides, saying that x squared equals b. Both of these represent the geometric mean of two positive numbers, where a and b are positive numbers. So let's do an example. Find the geometric mean of each pair of numbers. If necessary, give the answer in simplest radical form. So what is the geometric mean of 4 and 25? Okay, so geometric mean is the square root of the two numbers multiplied together. So we have x squared equals 4 times 25. So 4 times 25 is 100, and the square root of 100 is 10. So the geometric mean between 4 and 25 is 10. So what does geometric mean have anything to do with the altitude thingy-mabobber and the similar triangles things that were just going on? Well, see here, we have like h squared equals xy, h squared equals xy, because we did h over x equals y over h. And so from all the different proportions that we made earlier, we can cross multiply and create geometric means. So the length of the hypotenuse of the altitude the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. So if we're looking at the hypotenuse, if we're looking at the altitude squared is equal to xy. So the altitude ends up being the geometric mean of the two parts of the hypotenuse. This also works for the legs of the triangle as well. The length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So A, the length of the leg is the geometric mean to x times c. And B is the geometric mean of y times c. So let's do some practice problems. This is difficult. It's complicated. It is mixing geometry, statistics, and algebra all into one thing. So, it ain't easy. All right, skipping this. Forgot to take that out. Okay, so let's find x, y, and z. Okay, so let's start off with probably the one that is least difficult to remember. So 6 is this is the altitude, because we have a right triangle. It's the altitude of a right triangle. And so we know 6 is equal to the square root of 9 times x, or that 6 squared is equal to 9x. So we have this one is equal, 6 squared is equal to 9x, or 36 is equal to 9x, and then x equals 4. So now we know that oops, let's go back. Now we know that x equals 4. Okay, let's go on to y. So y is the geometric mean of 4 and 13. So we can say that y squared is equal to 4 times 13. So 4 times 13 is 52. So y is the square root of 52, but we can take a 4 out, because 4 times 13 equals 52, and then 4, so we get 2 and 2. So we can take a 2 out, and so that y equals 2 radical 13. I was hoping that my nope, that didn't work. What does this do? There's going to be a lot of editing. Yay. Okay, and so the last part is z squared is equal to 9 times 13. So z squared is equal to 9 times 13. So see how like z is the geometric mean, And so what you do is you take part of the hypotenuse that's closest to z, times it by the whole hypotenuse. With y, we took the part of the hypotenuse that was closest to y times the whole hypotenuse. So with z, we get 9 times 13, which is 117. And so z is equal to the square root of 117, which is 3 radical 13.
Yes, but you wanna say no. What do you mean? Hey, yeah. When you don't want me to move, but you tell me to go. What do you mean?
To the online quiz. All right, have a good one, and we will work a lot on this in class. I know this was difficult.